Welcome to another exciting educational video brought to you by Upvision Concept Academy. In this video, we'll be looking at integration in mathematics. We are going to be having a deep dive on integration. We'll start with the foundation and we'll see that integration actually is anti-differentiation. So it's going to be an interesting journey. So work with me and ensure you stay to the end of the video to see how we do integration and the different techniques for integration. First off, I have on the board that integration is the reverse process of differentiation, or we can call it anti-differentiation. Anti-differentiation. That means we are working from what we know in differentiation back to the initial expression that you have. So when we differentiate, we start with the derivative and then we find the expression from which we derive. Recall that when you are differentiating, that is, if you have the dx of this function, when you're differentiating, you take the power and multiply by the coefficient of the variable, and you also at the same time subtract 1 from the power. So you have 5 multiplying 4 to give you 20, and 5 dropping by 1 to give you 4. So that is how you differentiate polynomials. You understand? There are other derivatives that we saw in the previous video. Please check out our previous video on differentiation. We are building up on what we have taught in these videos. Let's learn how to link the videos and build on what we have learned before to do new topics. So this is differentiation. This is what we know. But we can come from here back to this place in a process known as integration. So this is the derivative of this, but we can integrate this and get back to this. So how do we do that? So if we're to integrate this, what you do is to add 1 to the power, and at the same time, you divide by the summation of the power. You know, divide it by the summation. So see what happens. 4 is the power of x here. When I add 1 to 4, at the same time, I will take the summation and use it as the denominator. So I am doing two things. I'm adding 1 to the power and dividing everything by the total of what we have at the power. So when 4 is added to 1, I have 5 up here, and I use the 5 to represent the denominator here. So it is 20x raised to the power 5 over 5. By the time you cancel 5 here 1, 5 here 4, we will now have this. So this is now effectively what we have at the initial stage. So this is integration. And integration is represented by this symbol. I will draw the symbol on the board. Sometimes you'll be asked to integrate, and the way it is done is to say integral 5x squared dx. So this is how the instruction for integration is. So it means this is integral, and this is the tendency. You are tending towards the x. So look at what you are integrating. You understand? Most times they can even give you a limit. They can give you a limit. That is, they will give you a limit for the integration, a number here and a number here. This is upper limit and lower limit. So they will give you a limit of integration. So we're going to be seeing some examples, some standard integrals, and we'll discuss it, and then we'll go to solve some questions. Okay, so on the board we have the basic standard integrals. So if this column is the function of x, then the integral of this function of x are the following. So if you have any polynomial is a variable that is raised to any integer. So x raised to the power n is the same thing. The integral will now become x raised to the power n plus 1 all over the summation n plus 1 plus c. We always add this plus c for integration, for integrals, because we have not determined the limit. There's a constant. There's a constant. So when we have the limit, let's say for instance we're given the limits, upper and lower limits, a and z. You understand? Then this c will disappear. But as long as we are not giving limits, we must always add the c to the standard integral, to the integrals. So if we have 1 to integrate, the answer is x plus c. Well, whatever it is you are integrating to, if for instance, say integrate 1 dx, that is when you now say x. If it integrates 1 d w, so it is now w plus c. You understand? That's why we are using x generally because it's dx. You understand? So, but it's not all the time that it will be dx. Okay, so for a is just a constant term that is not 1. It's just a constant term that is not 1. So it just is the integral is ax plus c. Sin x is the same thing as saying minus cos x plus c. Cos x is the same thing as saying sin x plus c. Sec squared x is the same thing as saying tan x plus c. That's the integral. Exponential x, the integral is exponential x. So this one will not change. Just add plus c. A raised to power x is the same thing as saying a raised to power x over ln x plus c. And 1 over x is ln x plus c. So please take note of these basic integrals, standard integrals. For integration and even differentiation, you need to know all these standards so that you will just go past this stage and start dealing with complexities. So this is just know them, the ABCs of integration. Know them first, because by the time we start doing functions, sometimes this kind of expressions can have functions inside. So you need to do some algebraic rearrangements, simplification, but you would have known these basic integrals. Understand? So just know it as the ABCs of integration. So move to just do some exercises to test our ability. I'm going to take this off and I'm going to give us some exercises to work on. Okay, so on the board is the following exercises. It says determine the following integrals. So we're going to be integrating. So like I said, master those basic integrals. Master them, because you just deploy it, what you know to solve this. Sometimes it could be that you need to do some simplification and arrive at the point where you now need to apply standard integral. So you just need to know that standard integral, so that you don't get entangled while you're trying to simplify some expression and you're also trying to remember standard integrals. For this first one is basic. The power of x there is 6. Just add on to the power and also divide by the summation of that power. So for number 1, integral x raised to the power 6 dx is the same thing as saying x raised to the power 6 plus 1 over 6 plus 1, then plus c. So final answer, x raised to the power 7 over 7 plus c. That's for number 1. Number 2 is also basic. You are given integrate 3 exponential x dx. This 3 is a constant, can come out. It comes out, and what you have is, if you integrate this one, it just becomes e raised to the power x plus c. So it doesn't change. It doesn't change. Okay, we'll go on to the next one, number 3. Number 3. So you see now, I'm now trying to introduce to you that you can bring out the constant. So if I have 6 integrate 6 over x dx, this is a constant. It comes out. It can be like this. It can be like this. It can come out of the integral, and you are left with this. And you know that this thing, we said that 1 over x is the same thing as ln x. 1 over x is the same thing as ln x. So 6 ln x plus c is the integral for this one. Number 4, I have integrate 5 sine x dx. Remember, you can bring out 5. So it's the same thing, 5 integral sine x dx. And the standard integral for sine is minus cos. So it's 5 minus outside cos x plus c. So that is the final integral of that one. Okay. The next one is sec square. Number 5, sec square. Integrate sec square x dx. There's a sec square, that's an x dx. Okay, so number 5, integral x sec square x dx. You know, sec square x integral is tan x plus c. Understand? So this is how it just it's like we're just doing the ABC of integration. Okay, so the next one is number 6. Number 6 is just 8 integral 8. It's a constant, right? So because I have the x here, I know that I will pair 8 with x then plus c. That's the answer for number 6. Okay. Then number 7 has a fraction. It's interesting. It's interesting. So you see now you now start seeing algebraic skills, addition and subtraction, fraction. Look at what you are giving here. It's the same thing you're going to apply, the same principle of adding 1 to the power and using the quotient, that's dividing the results. So this one is simply saying x 1 over 2 plus 1 over 1 over 2 plus 1. See, you add on to the power and divide everything by the results. Okay, so plus c, of course, plus c. So what is 1? This one is the same thing as saying, x raised to the power half plus 1 is 3 over 2, and half plus 1 again is 3 over 2 plus c. Of course, this one will go up. You're dividing by 3 over 2, so this one will go up. So I have 2 over 3 x raised to the power 3 over 2 plus c. So this is the answer. This is the answer. Okay. All right. So mind you, this is actually so that you don't get it twisted. So this is 2x over 3. You understand? This, what I did is correct, but I want you to just know that this is 2, you understand, x, then over 3, the rest power 3 over 2. Okay, so that's for number 7. Okay, so number 8 is 2 cos x dx. And if you check all this, what we are getting as answer, from the answer, if you differentiate, you get back the question. That is what integration means, anti-differentiation or reverse of integration. Okay, so we're going to solve number 8. So we have number 8 here, integral 2 cos x dx. So 2 can come out. Doesn't have anything to do with the function, can come out as a constant. But if you integrate cos x, you get sine x. So it's 2 sine x plus c. And remember, if I differentiate this one, I'm still going to get cos x. So number 9 is also tricky with a minus up there. It's tricky. Okay, so number 9, we have integrate x raised to the power minus 3 dx. So the power of x there is minus 3. So what are we going to do? We're going to add 1 to the power and divide by the results. Okay, so it is x raised to the power minus 3 plus 1 over minus 3 plus 1 plus c. Okay, so minus 3 plus 1 is x raised to the power minus 2 over minus 2 plus c. I can express this further. It's simply to say 1 minus 1 over 2 x minus 2 plus c, or I can say 1 minus 1 over 2x raised to the power 2. See? So we have done it the proper way. So plus C. So this is the answer for this one. The answer, okay? Or you can leave it like this. Anyone? Okay, so that's for number 9. And finally for number 10. For number 10, you have integrate 4 raised to the power x dx. Remember, just say this is the same thing as saying integrate a raised to the power x dx. The constant is the base and the variable is the power. So this one is just say a raised to the power x ln a. So this one is 4x 4 raised to the power x ln 4 plus c. So that's the answer for this one. See how I got it? Okay. All right. So just the advice for me to you is ensure you know your standard integrals and you just be applying to the question. Some of the question you might need to work on the what's it called, on the algebra or the fraction or on simplification or just changing the form, but you need to know the type of integral you are applying. So we'll move on. Okay, so we'll move on to integration of polynomial expression. So polynomial expression, we just have some operations in between. You have terms inside of it, and then you have the variable having powers of more than 1. See, this one is reading 4x cubed plus 5x squared minus 2x plus 7. So you have different powers of x. The highest is 3, so this is a polynomial. It's not a quadratic. If the highest power is 2, it's a quadratic, and if the highest power is 1, it's a linear. So this is a polynomial expression, and what we do basically to integrate this kind of expression is to integrate it term by term. So I have first term here, second term here, third term here, fourth term here. Integrate it using the standard integrals that I just discussed with you. So the standard integrals are just the ABC of integration. If you don't know the standard integrals, you will not be able to apply it in different integration problems or techniques. So you need to know the standard integral. So this simply just apply it to each of the terms. So the first one, how do I integrate this first term? This 4x cubed. I say 4x, then I add the power, 1 to the power, and divide by the base. I mean, divide it by the summation. Understand? So plus the same thing here. I add 1 to the power and divide. The third one, I add 1 to the power and divide. This one is a constant. I have 7x, then plus c. So let me just make this simpler. So I have it as 4x raised to the power 4 over 4. You see that's why it's good to simplify it further, because I can still cancel this one out. Plus 5x raised to the power 3 over 3 minus 2x raised to the power 2 over 2 plus 7x plus c. Okay, I can do this one again. 4 will cancel. So I have x raised to the power 4 plus, this is 5 over 3 x raised to the power 3 minus 2 will cancel, x raised to the power 2 plus 7x plus c. Okay, so this is the answer. But because integration is anti-differentiation, if I integrate this one back, I must get this. If I differentiate, sorry, I must get this. How do we differentiate? 4 will come down, right? And at the same time, minus 1 for the power. So 4x raised to the power 3 plus 3 will come down. When 3 comes down, this will cancel. I have 5x, then minus, that is, this one will reduce by 1. Then this one will come down and become the coefficient of x. Then the power reduced by 1. This one will disappear. So basically, I've gotten this one back by differentiation. But for integration, this is the answer that we have here. for this polynomial expression. All right. Okay, so we'll do this particular subtopic in this presentation are functions of a linear function of x. What does that mean? I have linear function. This is a linear function. Why? Because the highest power of x is 1. I told you that you have linear power of x is 1. You have quadratic, highest power of x is 2. You have polynomial, highest power of x is 3. So this is talking about functions of a linear function of x. So there is this function inside a bigger function. So linear power of x is a function. Okay, so how do we do it? How do we do it? Normally, you can expand this first by you just expand it, then you now integrate. But that's a no. That's a no. There's a fast way of doing it, or there's a standard way of doing this. And what we just do is to represent that linear function of x with another algebra, with another letter. So we first of all say let z be equals to 5x minus 4. Let. If we do that, then we can now write this expression like this. Integral z. So when we see 5x minus 4, we put z, raised to power 6. But this is still dx. It will not go because this is z and this is dx. So what do we introduce to neutralize this dx? We'll do an inverse. We'll introduce an inverse differential of dz dx. So it will now be x dz. Then we'll change this one to dz. Okay, now what am I doing? What am I doing? What I'm doing is that I want to ensure that the integral follows the process. So if I look at this now, I'm actually saying integral of z to dz is correct. At the same time, what I've introduced here, if I cancel it out, I will have my dz, dx. And this function is still defined as this. I don't know why you get. What I have done, I have just, this one is the same thing as this. Just that I am doing this one like this, so that this can have what I can work on. I can work on these two based on my standard integral. And when I've done that, I can now still introduce my dx, sorry. Okay, so I will write this again. What I did here is integral z raised to power 6, then dx dz, then dz. That's what straight away, that's what we do. Like this. Now, what is dz dx? From here to here, dx dz is dz dx is what here? It's equals to 5. If you differentiate this one, it's equal to 5. So, but if you twist it inverse, dx dz is just 1 over 5. That's what I want to put inside here. So this is the same thing as saying integral z raised to power 6, 1 over 5, then dz. I can now do this one normally. This one can come outside. It's a constant. Come outside. So let me just finish it up here. So I can put 1 over 5 outside, then integral z raised to power 6, then dz. So this one now is the same thing as saying 1 over 5, z raised to power 6 plus 1 over 6 plus c. Meanwhile, recall that our z is what? The whole of this. So I have the answer is 1 over 5, then open brackets, 5x plus 4 all over 6, then plus c. So this is the final answer. Okay, so this one too can be expressed as, let me finish up this question. This one can be expressed as, there's a 7 here, please note that that's the power. So it's saying, in the sense of saying 1 over 5 dot 5x minus 4 raised to power 7, then over 6 plus c. So I can multiply this and this is 30. Is 30. 5 times 7. This is 7 down here. This is 7 down here. 5 times 7 is 35. That's 1 over 35. Open bracket 5x minus 4 raised to power 7 plus c. So let's do some other ones. We have known the principle of this function of linear function. Let me quickly give you some other ones and we'll just look at it and wrap up the video. So if you have integral of cos open bracket 2x plus 5 then close bracket then dx. This one too is the same thing as there's a linear function inside here, and then there's a cosine that's right. So this can be written as, say, let z be 2x plus 5. All right, then integral cos z, then I will now inverse dx dz, then dz dx. What I'm doing here, what I'm doing here is to just ensure that the linear function is differentiated relative to x and inverted and brought out. So if I differentiate this linear function inside here, the answer of the differential is 1 over 2. Sorry, is 2. Then if I invert it, it is 1 over 2. So I bring that 1 over 2 outside. Then I still say integral cos z dz. So 1 over 2 outside, cos z, if you integrate it, you get minus sine z plus c. But our answer should not be in z, it should be in this. So minus 1 over 2, then sine, open bracket, 2x plus 5, then plus c. So this is the answer for this one. That's the answer for that one. So if you differentiate cos, you get sine, not minus, sine. Please, it's not minus. See, you have to understand, know your standard. I thought I was doing differentiation. When you are doing integrating cos is going to sine, it becomes sine, and there's no minus. So just remember to recall what you define z as. Okay, let's do another one. Let's do another one, the compound one. So if I have okay, let me do this one. So integral sine sec square 4x dx. So this is another function of linear function of x. So the linear function is this one now inside here, and there's a bigger one outside. So again, let z be 4x. Let z be 4x. Therefore, integral sec square z. Then I will now differentiate the linear function and invert. So I'll invert. So this is dx dz and dz outside. So the linear function, the differentiation, if I differentiate it, it's 4. If I invert it, it now be 1 over 4. I bring it outside. Then integral sine square z dz. So differentiate this one now. Integrate normally. If you integrate sine square z, it's same thing as saying tan z, 1 over 4 tan z plus c. Now tan z does not exist here, but I define z as 4x. So 1 over 4 tan 4x plus c. So I hope this video has been informative for you. I'd like to thank you for viewing.